Welcome, everyone. Grab a seat, get comfortable. Today, we're diving into a really special explainer on the geometric roots of the universe. Specifically, we are unpacking Chapter 5 of our space theory. Now, this is a framework that physicists have literally been dreaming about for over a century, a way to geometrically integrate relativity and quantum mechanics. If you've ever looked at the fabric of reality and wondered how the macro and the micro actually fit together at a fundamental level, well, you're in exactly the right place. So, let me start by throwing a pretty profound question your way. Ever since Einstein's 1905 photon hypothesis, we've known that light, which everyone thought was just a pure electromagnetic wave, actually has particle-like properties. But what if we flip that completely on its head? If light can act like a particle, could a particle with mass, say an electron, actually be a wave? It sounds crazy, right? But this Socratic leap of logic is exactly what led Louis de Broglie to his matter-wave theory back in 1924. And let me tell you, this paradigm shift completely upended our understanding of the universe and laid the entire foundation for modern quantum mechanics. All right, let's take a quick look at today's syllabus. First, we'll cover de Broglie waves and the double-slit experiment. Second, the R-space electron model. Third, we'll look at a few other geometric models. And finally, we'll wrap up by comparing all three theories. Okay, Section 1, de Broglie waves and the double-slit. Now, let's look at one of the absolute biggest mysteries in physics. If you fire electrons, which, remember, are particles with mass, one by one at a barrier with two tiny slits, your intuition tells you they should just hit the screen behind it in two solid clumps, right? Like bullets hitting a wall. But they don't. Instead, they form this interference fringe pattern. This means a single electron is somehow passing through both slits at the exact same time and literally interfering with itself. No way, right? But this isn't just theory. Akira Tonomura's team brilliantly proved this back in 1989. And the culprit? De Broglie's matter waves. To really wrap our heads around these waves, we need to contrast two crucial concepts: phase velocity and group velocity. Keep it simple. When you look at a wave carrying a particle, the phase velocity is just the speed of the individual wave peaks. The group velocity, on the other hand, is the speed of the wave packet, that overlapping beat of the waves. So think of it this way. One is the speed of the individual ripples, and the other is the speed of the whole bundle of ripples moving together. Take a look at this graph. You can clearly see how the overlapping waves form that packet. Now, here is the kicker. In quantum mechanics, the actual energy, the information, and the localized particle itself, that chunk of probability, travels at the group velocity. The classical speed of a quantum particle matches the group velocity of these probability waves perfectly. And that, my friends, is exactly why an electron can act like a wave, overlap, pass through two slits, and interact with itself on the other side. Moving right along to Section 2, the electron model and R-space theory. Let's break down the logical steps here so we can geometrically demystify this. First, in our space, when photons project into our spacetime, their phases alternate, which projects a wave. Second, electrons are fundamentally different. Their rotation vectors orbit each other, kind of like binary stars. And third, this specific double rotation is exactly what generates the electron's wave nature. Let's actually look at the geometry of this. To make this intuitive, picture a binary star system, where two stars orbit a common center of gravity. In the R-space model, an electron has three rotation vectors, x, y, and z. As you can see in the diagram, the x and y vectors are continuously orbiting each other under the influence of the z vector. They are completely locked in this intricate double rotation orbital dance. Now, what happens when we project this down into the spacetime we all know and love? Imagine if we only look at that red x factor and pretend its secondary complex orbit just doesn't exist. If we unroll that phase circle and project it straight into spatial dimensions, that x factor just keeps pointing in the exact same direction. If that was the whole story, you'd get no alternating wave pattern whatsoever. But, and here is the absolute climax of this mechanism, the x vector isn't flying solo. It's participating in that orbital motion with the z vector. Because of this extra secondary rotation, the x vector's direction is constantly forced to rotate as it moves. It points right for positive, up for negative, down, and so on. When we project this into our spacetime, it continuously alternates, positive, negative, positive, negative. This brilliant piece of geometry is literally what creates the electron's wave nature. And what's really fascinating is that, unlike photon waves, this double rotation means the electron's wave projects proportional to the distance squared. All right, let's expand our view. Section 3, other geometric electron models. First up, we have the 1997 Williamson and Vandermark, or WVDM, electron model. This model brings a truly groundbreaking idea to the table. What if an electron is actually just a single photon? Specifically, a single photon trapped in a self-confined, twisted double-loop donut shape, a toroidal topology if we're being formal. What makes the WVM model so compelling is how naturally it explains things. Because the photon travels at the speed of light within this specific double-loop toroidal confinement, its phase only returns to its original state after a full 4-pi rotation. Geometrically, this perfectly explains the electron's mysterious spin 1/2 symmetry. On top of that, this localized toroidal containment of the photon's electromagnetic field natively generates the electric charge and magnetic moment that we actually observe. It's like a giant puzzle perfectly coming together. We also absolutely have to touch on the legendary twistor theory, proposed by Roger Penrose in 1967, which was designed to integrate general relativity and quantum mechanics. The core, profound claim of twistor theory is that the standard four-dimensional Minkowski spacetime we live in isn't fundamental at all. Instead, it's just a secondary projection of a deeper, complex spinor space called twistor space. And this perfectly aligns with our space's claim that a reality is just a projection of deeper geometric rotations and phases. Let's put these ideas side by side. On the left, we've got the WVDM toroidal photon loop. On the right, the Hopf vibration, the mathematical structure of twistor theory. Visually comparing these anchors a shared geometric truth. Whether we're looking at the internal structure of an electron or the fundamental twisted threads of space itself, this underlying toroidal or donut structure is deeply inherent to all of these advanced models of the universe. Which brings us to our final synthesis, Section 4, a comprehensive comparison of the three theories. If we systematically walk through this table, the alignments are just striking. Regarding spacetime, both twistor and our space agree. The Minkowski space we experience every day is a secondary, derived projection. When it comes to the electron's image and spin, both WVDM and our space give the electron an actual internal geometry, a double rotation or twisted loop, which physically accounts for spin 1/2. Our space essentially acts as the ultimate bridge here. It uniquely combines twistor's concept of derived spacetime with WVDM's concept of an internally rotating geometric electron structure. So what does this all mean? What's the main takeaway from today's explainer? Well, it takes the magic out of quantum mechanics. Complex properties that physicists usually just describe with abstract math, things like U1 internal symmetry, magnetic moments, and charge, are ultimately just manifestations of pure geometry. They are the physical results of angular momentum and internal rotation projecting outward into a space that is itself just a secondary shadow of a deeper reality. And that leads me to a final, profound question I want you to chew on until our next explainer. If our Minkowski spacetime is truly just a secondary projection of rotation vectors from a deeper R space or twistor space, is the space that we perceive and move through every day truly a fundamental existence, or are we just swimming through the geometric shadows of something infinitely more profound? I'll leave that to you to think about. That's all for today's explainer. Keep questioning the fabric of reality.